Hello, everyone. It's a really great pleasure first to see many of you, but also it's really great pleasure for me to introduce Shaf. Shaf would be presenting today what they're doing at LabDonkey. And just to give you a quick background about Shaf, he's currently the CTO of LabDonkey, which is really lab automation software company. You would say, okay, there's so many out there. What's the difference? It's really the idea how they're focusing on the orchestration, scheduling, and so-called recovery first automation systems. I think this is something which everyone who has been doing automation would appreciate. And to give a quick overview, he has spent more than 30 years building complex software systems from industry like flight simulation, nuclear power, finance, healthcare, and we're happy that he have decided to move to lab automation. I think that would be also become quite prominent from the talk. And today he would focus, not today, but in general, in his current role, he is focusing on helping laboratory to integrate and control multi-vendor automation systems through flexible software-first platform. And Shaf, please give it away. We're looking forward.
Thanks, Nikolai. Really appreciate the opportunity. I've shared my screen so you guys should see. So I'll just get going then. I can't see everybody from my screen, so if there are any questions, I'll leave enough time at the end for questions. So just bear with me. Okay, well, let's go then. Thanks everyone for joining. I'm appreciative of this opportunity, and it's always great to be connected with so many of you already. It's always fun to see familiar faces. I'm Safwan. Saf to my friends and anybody who wants to collaborate. I'm the CTO of LabDonkey, and today I want to talk to you about something that I think a lot of us in this room have felt firsthand. Lab automation is one of the most exciting opportunities we have to improve how science gets done. In fact, as Nikolai said, I've been in many different industries, and this is the most fun I've had in over 30 years. But it's also one of the areas where I've seen the most frustration, the most wasted investment, and honestly, the most avoidable mistakes. So let's talk about how to get it right. Before we get into what goes wrong, let's acknowledge why the pressure to automate is so intense right now. So regulatory expectations keep rising, throughput demands keep growing, reproducibility is under more scrutiny than ever, and for a good reason. Back in 2016, Nature surveyed over 1,500 researchers and found that more than 70% had tried and failed to reproduce other scientists' work. 70%, 70. More disturbing is more than half couldn't even reproduce their own work a year later. That was a decade ago, obviously, and the pressure has only grown since. On top of that, experienced operators, the people who really know how things work in your lab, they move, they retire, they get promoted. All these forces are pushing labs to automate faster. And that urgency, it's part of the problem. So here's the paradox, as we call it. Automation has the potential to transform lab productivity, higher throughput, better reproducibility, more consistent outcomes. But many automation projects don't deliver on that promise. And it's usually not because the technology failed, but because the foundation wasn't ready. Labs try to jump straight from manual process to fully automated systems. And when we talk about fully automated systems, I mean the ones with the robots, SCARAs moving plates around. And that jump is where things break down. Many automation initiatives fail to deliver long-term value. And that's the reason. And the reasons are surprisingly consistent. The systems become difficult to maintain. That's something we hear all the time. There's a lot of dead systems. Every client I've talked to, they have a system that's just sitting in the room doing nothing. The workflows are hard to adapt when something changes. And scaling, that becomes its own project. The important thing to notice here is the problem usually starts before the automation begins. It's not the robots or the software that fails. It's what's underneath them. And here is the hidden reality. In most labs today, your workflows are fragmented. Protocols on knowledge are spread across paper, Word documents, PDFs, SOPs, version 1, version 2, final, spreadsheets, instrument software, and maybe the most important one is individual expertise. The things your experienced operators just know. The result is that the workflow exists in many places, but nowhere fully. There is no single source of truth. And there's no complete picture, and that fragmentation has consequences. This is what happens when automation is placed on top of that fragmented foundation. You end up with a system that are hard to maintain because the underlying processes were never properly defined. Difficult to change because there's no structured way to update what's running. And fragile when something goes wrong because the automation inherited the same brittleness of the manual process it's replaced. You're basically, essentially encoding the chaos, not solving it. So what's the alternative? It's not to avoid automation, definitely not. It's to take a more practical path to get there. Automation works best as a staged process. Instead of jumping straight to full automation, you start by digitizing your workflows. Then you standardize your processes. You capture your instrument interactions in a structured way. You capture the data out of the instruments programmatically. And you make sure operator actions, the human decision and judgment calls are part of the system, not separate from it. And that's a very important part. Each steps build the foundation for the next. And that's where I want to pause for a second on this point, because I think it's one of the most underappreciated risks in any lab. Every lab has what we call tribal knowledge, the thing that experienced people just know. This is timing tweaks, visual cues, or an example of if the solution looks slightly cloudy, wait 5 more minutes. That kind of knowledge is tribal knowledge. And when that person leaves, that knowledge leaves with them. And the shift we're talking about here is turning tribal knowledge into institutional knowledge, making it structured, repeatable, scalable. So it doesn't depend on any single person being in the room. That is the goal. The goal is to make sure that anyone can walk into the room and with a bit of training, very little training, hopefully, can get the job done. And this is the key insight. When you digitize properly, you're not just putting paper into a computer. You're creating the foundation that makes everything else possible. Experimental protocols become structured workflows. Operator actions become captured and traceable. Instrument interactions become standards. The data we're collecting, while we might not need it today, we might need it in a couple of years because we know our AI might find value in that. But critically, workflows can evolve without breaking the system. That's when automation becomes predictable and scalable, not before. Let me show you how this comes together in practice. So this is an overview of the LabDonkey platform. On the right, you have steps. That's where we digitization starts. We turn SOPs and operator actions into guided digital workflows. In the center, we have suite. That's the full automation layer. It's orchestrating the entire work. So that's when robots, as in SCARA robots, are involved. And around them, we have the building blocks of what makes LabDonkey beat. So if we have shortcuts, that's repeatable actions. I'll show you a bit of that at the end. Drivers, that's our consistent control layer across instruments. That's the one that takes care of making sure there's logs, repeatable error handling on all of our drivers. CLED 2 is for open protocol support and scripting for adding resilience, recovery, and scale. Let me walk you through each one just to give you an idea of what that means. So let's start with steps. Steps is where your journey begins. It replaces paper methods, Word documents, PDFs, spreadsheets, and calculators with guided digital workflows. Your operator follow clear step-by-step instructions with embedded videos, photos, data capture, file movement, file conversion, and so on. This reduces training time dramatically and makes it straightforward to run complex lab processes without navigating instrument software. That's another bit that's really cool, and I'll show you that. Think of it as turning your SOPs from documents people read into workflows people follow. And then when you're ready to move from a digitized workflow to a full automation, that's where Suite comes in. Suite connects and orchestrates robots, instruments, and workflows across the entire work cell. It uses deterministic scheduling and what we call recovery first execution. Well, I'll tell you that in a bit, but basically it's all about repeatability, and that's more than speed. That's what when we talk about automation, we want that repeatability. Meaning the system designed from the ground up runs moving when problems occur, not just when we stop and wait. It also includes operator guidance and built-in traceability, so your operations are reliable and audit ready, another big part of proper automation. And you can deploy it, of course, in the cloud or on-prem always, whatever fits your environment, really. Now, let me show you some of the building blocks of LabDonkey. Shortcuts let operator trigger instrument actions or full protocols with a single click. Think about what happens today. You have to log into that computer. You need to go find the routine, navigate through the vendor software, find the right function to execute, set the right parameters, then click go. With shortcuts, we eliminate that. You execute tasks instantly, even during active workflows when the schedule allows, without stopping the system or switching between applications. That alone means that 9 out of 10 users never have to open the vendor software. And behind those shortcuts are our drivers. Now, drivers expose the full functionality of each instrument. While LabDonkey may use only a small set of the features, we expose every action, every parameter. So the teams aren't restricted to what the vendor's UI chooses to show them, and isn't restricted to what we think are the functionality that we need to expose. So our goal is to expose as many of the functionality as possible. Devices communicate through flexible interfaces. So we have our own pub/sub internally that we use that you can plug into. We have REST, we have CLA2 servers, and the next thing we're doing is NATS and gRPC support. That's coming very soon. The point is you get full access to what your instruments can actually do through one consistent layer. So you hide all of the complexity of the instruments. And those of you who follow the CLA2 standard, we fully supported. A recent feature that we have implemented in LabDonkey discovers existing CLA2 drivers and connects to them with a single click. This functionality automatically imports everything into the LabDonkey ecosystem. So when we put a device that's CLA2 compliant and connected to LabDonkey, all of its functionality is available in Suite, steps, shortcuts, and drivers, without any duplication, without any rewrites, without any custom code. This matters because it means you're building on an open standard. You're not locked into proprietary integrations. You can have your own drivers for your own custom devices. And your automation becomes more portable and future-proof. And finally, for labs that need more flexibility, we offer scripting, both code and drag and drop. LabDonkey scripting lets teams modify and extend workflows, SOPs, drivers. You can even modify implementations of code in the driver itself without rebuilding everything from scratch. If you need custom behavior, automation rules, a specific integration, things that we haven't thought of or things that are unique to your enterprise, you can build it. This gives advanced users full control while keeping execution simple to the operators. So the operators don't have to see any of this, so it's easy for the day-to-day usage. Now, I want to come back to something I said at the beginning. The goal is not just to automate. It's really more to build systems that are resilient. And what does that look like? When something fails, the workflow doesn't just stop. That's a core thing of LabDonkey. It can retry, recover, alert, or route to the next safe step. If an instrument is unavailable, you should be able to swap it to an equivalent one without redesigning the whole workflow. Protocol changes are version controlled. You always know what's changed, when, which version was used, and everything is recorded in an audit trail. For example, who did what, when it happened, how the system responded. Resilience means the system can recover, adapt, and stay traceable when real lab conditions change. Because in real labs, conditions are always changing. Here's a quick high-level view of some of what's available across steps and suite. I won't walk through every item, but I want you to notice just the breadth of some of the stuff we do. Customizable driver, human-in-the-loop tasks, to workflow planning, error handling, subroutines, and pendant-based robot teaching. The point is that this is a complete platform, not a point solution. It's designed to cover the full spectrum from digitization through to full workflow orchestration. What we're trying to do is give you a system that can grow with you instead of saying, oh, let's go full automation from day one. Now, if there is one slide I'd like you to remember from today, it's this one. Automation starts before full automation. The journey goes, you connect your instruments and validate your protocols. That's our LabDonkey shortcuts. You digitize your workflow. That's our LabDonkey steps. You capture your instrument interactions along these two, and then and only then you automate with confidence. That's when you say, okay, I've done my work, I've done all the hard work, now I want to bring this and go into a full automation system. Each stage builds on the last. So you don't have to commit all your budget or commit everything into one shot. You start with the smallest of the stages, you get value on its own, right? So shortcuts hides the complexity of the instruments. Even if you never move to the next step, you would already be ahead. Just shortcuts alone can simplify your lab. Then when you digitize your workflow, then we're collecting that data, we're integrating with your systems, we're reducing those touch points. So every step gives you value that I would say, I believe it hasn't happened yet, but I believe at some point, somebody is going to say, Saf, we want to do full automation. And they might just stop at LabDonkey steps and say, actually, there's no point. This is good enough. So why should we? So you don't have to do everything at once is what I want you to take from this, is you could do step by step. So the goal is not just to automate. The goal is to build systems that survive change, systems that recover from failure, systems that keep delivering value long after the initial project is done. That's what's getting lab automation right looks like. And that's what we're building at LabDonkey. We don't want a LabDonkey system to suffer because a change in the science means that everything dies. You should be able to build on that system, grow it, change it, and improve it on your own if need be, and if not, with little change. Now, before we go into, I open it up for questions, I want to show you what this looks like in practice so you get an idea of everything I've just said and how we do it. I'm going to do a quick demo of two things. Just going to check the time. I think we're good. Shortcuts and steps. First, shortcuts, I want to show you how simple it is for an operator to trigger an instrument action. No navigating vendor software, no switching between applications. One click, that's it. And then steps, I'll walk you through what it looks like for a scientist to follow a digitized workflow, how it's built step by step with instrument interactions and data capture built right in. This is what replacing paper SOPs will feel like on the ground. So what I'd like to do now is I'm going to stop sharing the slides. There we go. And I'll switch to LabDonkey and show you what that looks like. This is LabDonkey. It works in the browser. So as I said, I want to show you a couple of things that matter. One is the shortcuts. And I think what I'll do, I'll just quickly share my phone camera. If I can get that going. Voila. So these are shortcuts to my devices. So in shortcuts, I have a bunch of instruments on my work cell or across my lab. They don't have to be in a work cell. And I would like to go to this Q instrument, which is right now just sitting right next to me. I'll just bring that over, if you don't mind, a little bit of a, there we go. So shortcuts, as I said earlier, is a way for us to simplify things. So let me just zoom in a little bit. There we go. All right, so I have my BioShake and I have my shortcuts. And those shortcuts could be as simple as lock the ELM, unlock the ELM, or have predefined protocols running on this. So I want to shake clockwise for 250 RPM. These are settings that the users could edit, 250 acceleration of 1, and for 5 seconds. And if I click on this, you'll see it will start shaking. Now, I could do that with any device, whether it's a Hamilton, it's a reader, a Mantis, any of those devices, all this. I suppose there's a question. I heard a ding.
No, it's not a question. It's just
No, it's just a comment. Sorry, didn't want to interrupt.
Oh, no problem. So basically, yeah, it's as simple as that. You create shortcuts. So we have a number of shortcuts for different projects. So you could see, for example, if you've ever used the BlueCat Bio, you would appreciate how difficult it is of a software to use. So it hides that complexity at the end. Other things I want to show you is basically our LabDonkey steps. So I'm just going to quickly show you what the design of it would look like, and then show you what happens when you run it. I think I can hide my phone for this. There we go. So how do we digitize your lab? So to digitize your lab, we need to give you something that is better than paper. So how did we come to this? Is because we were in a lab and they had a digital SOP that happens to be 6 to 8 pages, and people were not following those because they would memorize them. They don't read all the minor changes. And every time there was a change, that change wouldn't be shared with everybody in a timely fashion. And so things got lost. And so we decided to build LabDonkey steps. The good thing is we were able to build it because our architecture is built for this. The shortcuts is the foundations. Our drivers are the foundation for our shortcuts. So it was very easy to build. These screens would be built by your end user. You don't need us to do these. And basically, it will look like this. So I'm just going to run this and walk you through what a test SOP looks like. This is just one that we use to show various set of features. So a screen, for example, that could show information. That information could be written, could be coming from a LIMS, from a file, from an API. It doesn't matter. We can collect data, such as this. We can do barcode scanning. I didn't connect my barcode scanner, but it looks like this. I actually love this little feature because if you're using Eppendorf plates, not only would we get you the lot number and the product number based on the barcode, we can get you all certificates for that one. And then we have our little calculator. So that calculator, I could say I have 3 plates. It calculates all of my reagent. The next step to make this better is, how do I prepare this reagent? How do I prepare for this? There's a video that I could play back that shows me step by step. That means I could go on holiday for 6 weeks, come back, and still know how to do this without any help. Or have somebody who's relatively new or junior and say, hey, follow this. Let's see how well you do on your own. And eventually, they become experts quickly. Then we have our checklists. We have pictures you can upload, just like we did with the videos. And this is where it gets better. So far, what I've shown you is all the things I've been talking about. We've replaced your Word documents, your paper. We've replaced your PDFs, your final, V5, final, all of that things that you all know what I'm talking about, right? Now, everything is in here. Now I want to get this to the next level. So I come in here, I select these wells, and I click next. Now, I want my Mantis to dispense in these wells. Typically, what I have to do is go to that computer, open the software, find the right protocol, find the right dispense list, correct it, and click on it. While here now, I can click on dispense, and it will dispense directly into those wells. The beauty of it at the end of the day is that if the protocol I'm using is being updated and improved by somebody else, only that one person needs to do that work. Everybody else in the lab will just click on that button and it will load the correct version of the protocol every time. And just a few more screens, and then I'll take your questions. So shake plate, same thing. As you can see, the parameters are set. I don't have to memorize them. I don't have to open the software. I just come in here, click on this button, and the shaker will run. And finally, a few more things: images, plate definitions, even instructions on how to load specific plates, timers that might be of value, and the ability to have files move across computers, machines, and being rewritten in a good way. And the last thing I want you to take from this is, why is this good? Because we collect all the data at every step. So if Max runs this on Monday, it takes him 60 minutes. Alex runs it on Tuesday, it takes her 75 minutes. I run it on Wednesday, and it takes me 65 minutes. Well, we're all doing something wrong. One of us might be right, or we're all doing something wrong. By collecting this data, we can keep track of what's happening to the assay, which means when the result is not looking good or looking a bit off, you can go back and say, oh, staff left that plate out for 15 minutes instead of leaving it out for 5 minutes. And that could have been the reason why the data is incorrect.